Hello everybody. In this video we're going to start our Monte Carlo simulation where we're going to create random values for all of our key variables and then use those random values for our series of NPV calculations on the project. You will be using your adjusted project, capacity adjusted project. We're going to do a simple capacity adjustment, just basically what you've already done. There's more advanced ways to do it that are going to control for the different random variables that come out. Anyway, so our first step is here for our sales. Get this out of the way. This is a sales growth. So your average sales growth is just going to be, your mean, even with the quadratic, which changes every period. Go ahead and just pick a single average. That'll be fine. And then the standard deviation comes like from the last project where we converted their standard error into a percentage. We'll just come down here and I'm really quickly going to go ahead and highlight everything and delete it to, say, K205. I'm just going to get rid of those guys. And all you'll do is start, you go into data, and then data analysis, and the random number generator. For this one, we're going to use a normal distribution. So I'm going to click here on normal. The mean is going to be 4%. So it's 0.04, and the standard deviation is going to be 2.6%. And I want 10 variables, so that's one for each year, and then we're going to do 200 simulations. So I'm just going to click OK. Oh, sorry, let me delete that. Bring it back up real quick. Data analysis, random number generator. I need to pick where I want to put it, so I'm going to start it there. And now I'm going to click OK. So here's our annual sales by, apparently it doesn't want to go up there, by year. So in this case, apparently in run 1 we have a reduction in sales the first 2 years, and then we have an 8% increase, 4, 5, 5, 4, 1.776, 2. So it's just random as you go through here. Just a random draw on this distribution. You'll apply this sales growth for each year. So when you see like negative sales growth at the beginning, that's bad for our NPV project. If we had negative sales growth at the end, that would be better. So this is just a random setup, and you'll see that there are 200 observations associated with it. So that's the sales setup. The price setup is going to be a little more complicated. Let me go ahead and highlight my group here. Say K200, K230, and delete those. I'm going to go ahead and delete these guys. Our first step is to generate a series of random numbers from a uniform distribution. So I'm just going to go over here under data and data analysis again, random number generation. Here I'm going to pick a uniform distribution between 0 and 1. Select my output range, which is going to start right there. It'll warn me that I'm overwriting. And again, I want 10 variables, 200 as we go down. So there's 1 for each year and then 10 for each run. Go ahead and click OK. So now I have my new set of random variables that have been calculated. Now what we want to do is use a triangular distribution. And just as an example, with drift. As an example, my base price, my average price, my expected price is $8 per unit. We're going to include a 0.5% drift. So that's going to allow the price to deterministically go up over the 10-year period. And that's a control for issues of inflation. The value of the drift is just going to be the base price times 0.05%. And I've fixed the min and max price here. Min price of $7 and a max price of $10. So all we'll do is draw from a distribution, and then we'll add the drift to it, so that we slowly move up over time, 4 cents per year. Here, I know it's a very complicated, so I'm going to leave it up for a second so you can look at it slowly. But it's going to be D1, which represents the average price. In your case, it would be the price with an NPV of 0 at 6 years, minus H1, which is the min price, quantity divided by J1, which is the max, minus the min. So these have been dollar signed. If it's greater than or equal to M3, which is my first random uniform variable, then the price is going to be the min price plus F1, which is my drift term, times $2, which is the year, minus 1. So we don't add the drift the first year, but we add it as we go along, plus the square root of my random term times the difference between the mean value, which is the base value, the average value, minus the min times max minus min. Again, notice the dollar signs. If it's not greater than or equal to M3, then it has to be less than, in which case we're going to apply this second equation here. Again, be careful about the dollar signs. So we don't want to do drop and drag. I'm going to show you a little different way to do this. I'm going to come to the home. We're going to use the fill comment. So we're going to start by filling sideways. So I'm going to go from B3 colon to K3. And that's where my 10 is over here. And just hit return to highlight that, and then come down to the fill command, and I'm going to fill to the right. So that's just going to copy everything down. And then I'm going to, again, come from B3 colon, and I'm going to go down to the bottom. You can go over, so I'm going to say K205, for example, and highlight all those, and now I'm just going to do the fill down. So that's populated everything that I'm interested in. I can come down here to the end, and where there's some bogus values, we'll just go ahead and delete it. So this represents a random draw of the sales price. So in this case, we had a price that came out starting off at 9.5 and apparently randomly kind of decreased as we went down. So we're not sure what over time what the sales price is going to be. So this is kind of controlling for sales prices going down, sales prices going up, etc. We just think that the average is going to be 8. Alright, in order to get the variable cost associated with it, I'm just going to highlight everything and go ahead and delete it. Come back here to my sales price, and I'm putting up here to highlight everything. Now I'm going to copy, come over here to my VC, and I'm going to paste. So our first step is to change the random variable. If we don't change the random variable here, we'll have a perfect correlation, which is exactly what we don't want. We want it to be random. So again, under data analysis, random number generator, again between 0 and 1 uniform, our point is going to be right here as the beginning. We go ahead and hit OK, get my warning, and go ahead and overwrite everything. So you can see that the random numbers have changed, and therefore the price has changed. The drift value for our VC is going to be 1% instead of 0.5%. Raw materials, there's not a whole lot of negotiating on because they're commodities. Their margins are already really low. And if you don't want to buy it at that price, somebody else would be happy to. This drift controls for issues of increasing variable costs. I'm kind of running out of time here, so I'm going to go ahead and all you'll do is change your base variables. So it's the base for me, I'm just saying, is 4. The minimum value is going to be 380, and the maximum value in this case is going to be 5. So that's updated all the sheets. All right, I'm going to go ahead and click save, and I'll come back to show you the overhead and the whack.